XStress, how the product works. What is plant stress? Stress naturally occurs during poor growing conditions, abiotic stress, and during attack by insects and diseases, biotic stress. Stress always leads to depression of plant health, crop yield, and food quality. During stress, plant cells produce increased levels of peroxides, reactive oxygen species, ROS. ROS are highly destructive to cell structures. In response to increased ROS, the plant produces more ethylene, closes stomata, and starts to shut down photosynthesis, reducing nutrient uptake essential for plant health. Hypersensitive reaction. Use of XStress reverses the effects of this stress response. XStress is a specifically designed foliar fertilizer to help combat stress. XStress contains the essential microelements required for enhanced plant health, including the correct proportions of iron, zinc, manganese, and copper, combined with additional magnesium and glycine. Applications of XStress allow the plant to maintain photosynthesis and increase the level of anti-stress compounds, jasminates, glycine, antioxidants, anthocyanin, glutathione, linoleic acid, and other proteins, SAM, controlling the levels of ROS, hydroxides, ammonia, and ethylene. Reduced levels of ethylene lead to visibly better fruit, more yield, and longer shelf life. Apply XStress prior to cold weather. During conditions of high UV light, use regularly to prevent damage from saline irrigation water, high temperatures, or when water is not freely available to the plants. Control of cellular reactive oxygen species, ROS. Control of cellular ROS. Study looked at the protection XStress gave against cellular level stress. Plant stress is often associated with an increase in reactive oxygen species, ROS, causing cell death, leading to leaf damage, reduced photosynthesis, and impaired plant growth. Laboratory studies were set up using tomato plants, comparing XStress-treated plants to control. Oxidative stress was induced by using methyl viologen herbicide. Leaf damage, as concentration of the herbicide increases to 500 micromole. Leaf damage in the control increases to 15%. XStress prevented any leaf damage, showing it protected the plant against ROS. Chlorophyll fluorescence. As herbicide damage increases, chlorophyll fluorescence decreases by 21% in control. Reduced fluorescence indicates less photosynthesis. XStress prevents any damage or loss in photosynthesis. Control of ROS. Conclusions. XStress protects tomato plants from oxidative stress. XStress prevents physical damage to the leaf. Consequently, chlorophyll fluorescence remains high under stress, giving greater plant growth under stress conditions. In absence of any stress, plant growth is improved by XStress micronutrient formula. Control of salt stress. Saline water is a major cause of plant stress and reduced yield. A trial was set up to see if XStress could prevent the effects of saline water reducing growth by measuring photosynthesis. XStress was compared to a control of plain water. Tomato plants were treated with XStress, and 2 days later the tomato plants were irrigated with saline water twice, equivalent to 1/5 seawater. Measurements were made of photosynthesis and antioxidant levels. Effect on photosynthesis. Plants treated with XStress recover rapidly after initial shock to 100% photosynthesis by day 10. Control plants never recover, remaining at 75% of pre-treatment photosynthesis levels at day 17. Main driver of recovery is improved stomal conductance, increased production of anthocyanin. XStress increased the level of antioxidant production by 13% compared to untreated. In absence of stress, XStress maintains extra antioxidant levels. Anthocyanin controls damaging ROS, reactive oxygen species, produced in the cell during stress. Salt stress. Conclusions. Saline water can have a dramatic effect on plant photosynthesis. XStress allows plants to recover to 100% of pre-treatment levels. Under salt stress, XStress induces production of anthocyanin, flavonoid, to protect plant cells against damaging reactive oxygen species, ROS. Increased levels of antioxidants stimulated by XStress help reduce infection of diseases such as powdery mildew by 50%. Cold stress, control of cold stress, cold temperatures induce stress response, decrease in photosynthesis, and increase in ethylene. Leaf damage often seen as scorch, flowers and fruit often aborted because of cold stress. Pre-treatment with XStress prevents plant stress response. Plants pre-treated with XStress. Tomato plants chilled at 4 degrees for 1 night. Photosynthesis measured after 3 days. XStress treated plants were 35% less stressed than control. UV light. Control of stress caused by UV light. High UV light can be physically damaging to plant tissues, causing scorch. Plant response to high UV is to shut down photosynthesis. Grapevines are known to be prone to UV damage due to climatic conditions. Trials set up to look at effect of UV on grapevines and response to XStress. Grapevines, viticulture industry of great global and local importance. XStress reduces yield. Scorched berries reduces quality. High-stressed fruit can lead to poor flavors in viticulture. Laboratory tests. Dwarf Sauvignon Blanc plants were pre-treated with XStress or water. Control. Plants were subjected to a defined UV exposure for 2 weeks. Comparison of how plants responded to UV plus and UV was measured. Physical response to UV. With normal UV light levels, XStress increased berry weight by 13% and leaf area by 40% compared to control. This is due to the micronutrients in the XStress formula. When stressed by high UV plus light levels, XStress increased berry weight by 10% and total leaf area by 50%. By preventing leaf damage, plant weight. Control plants exposed to UV plus lost 20% of their total biomass. Plants treated with XStress lost only 5% of biomass when exposed to UV plus. XStress reduced the effect of UV plus stress by 19%. Photosynthetic response to UV. Plants taken from normal UV and exposed to UV plus. Photosynthesis measured before and 1 day after exposure to UV plus. XStress increased photosynthesis by 10%. In control plants, photosynthesis decreased by 25%. Antioxidant response. Both cysteine and glycine are important in antioxidant, anti-stress metabolism. For example, glutathione production. XStress increased levels of antioxidants significantly. Conclusions. Use of XStress can help prevent physical damage to leaves caused by UV stress. XStress reduces the loss in plant biomass caused by UV stress. Because of better plant health, berry weight increases when using XStress with or without UV stress. Plants treated with XStress maintain over 100% photosynthesis, even in presence of UV stress. Increased levels of antioxidants induced by XStress protect plant from UV damage. Disease stress. Panama disease. Bananas. Plants growing under stressful conditions are more prone to fungal disease. Where XStress was used as an anti-stress product, it prevented Panama disease from establishing in the crop by maintaining cell wall integrity and plant health. The fungi was prevented from infecting cells. Reducing stress worked as efficiently as the standard fungicide flutriafol. Tomatoes. Powdery mildew. Increased antioxidant levels help combat effects of diseases by using XStress. Disease levels are reduced by 50%. Lowering plant stress increases plants' ability to defend against infection. Water. Osmotic stress. Tomatoes. Spain. Tomato plants were put under water stress, reducing irrigation by 25% and 50% of normal. Malonaldehyde is the main breakdown product of linoleic acid, which is manufactured in response to stress. The lower the level of malonaldehyde, as a marker of oxidative stress, the lower the level of plant stress. In both cases, levels of stress decreased by around 50%. Grapes. Brazil. Severe stress was caused by high temperatures and reduced water. The upregulation of glucanase and peroxidase antioxidants help to counteract the effects of stress at a cellular level. Reduction of damaging radical superoxides. ROS in the cell is the beneficial outcome, leading to better growth and yield. Osmotic stress. Conclusions. Water stress through reduced irrigation or high temperatures, has a major impact on plant stress. Levels of ROS increase in cells, causing damage, reducing yield, quality, and plant health. Use of XStress and regulated linoleic acid, glucanase, and peroxidase to counteract stress. Levels of ROS decreased by up to 50% in treated plants. Ethylene control. During periods of stress, excess ethylene is produced. This is primarily to liberate calcium from cell walls to combat ROS. Excess early ethylene release, not for ripening, leads to weakened cell walls, poor fruit quality, increased disease levels. By using XStress prior to harvest, antioxidant levels are increased and ethylene levels decreased. This leads to increased shelf life of fruit post-harvest. Cucumber Spain. 3 applications, 10-day interval, pre-harvest. XStress applied at 1 cubic centimeter per liter. At day 4 post-harvest, XStress reduced ethylene production by 20%. Tomato Spain. 3 applications pre-harvest. XStress applied at 1 liter per 1,000 liters of water. After 5 days post-harvest, XStress reduced ethylene production by a total of 50%. Raspberry Spain. 2 applications, 10 and 4 days pre-harvest. XStress applied at 1.5 cubic centimeter per liter of water. After 8 days post-harvest, XStress reduced ethylene production by a total of 25%. Ethylene control. Conclusions. In all fruit pre-harvest applications of XStress reduced ethylene levels in all situations. By preventing stress, reduced ethylene levels prevent premature maturation in fruit. Shelf life increases. Fruit firmness increases. Secondary disease decreases. Botrytis. Waste decreases. Summary. Designed specifically for control of plant stress, improves plant health and nutrition in all circumstances, controls all types of stress from salinity, UV, high temperatures, osmotic, and disease, acts at a cellular level by increasing anti-stress proteins, reducing ROS and stopping excess ethylene production, improves quality and yield of fruit, as well as increasing shelf life.